So this video is going to teach you how to balance equations using the counting method. So you should have already watched Mr. Anderson's beginner balancing equations video. If you didn't, go ahead and go back and watch that. And this example is similar to when Mr. Anderson was doing the practice problems. He was basically using the counting method. He just didn't call it that. This method's a little more advanced than what I call the brick method, which was my previous video. So if you find that this is a little confusing, go back and watch the brick method video first. So when we're doing the counting method of balancing equations, we want to start by rewriting the equation as I've done. So you can see the original equation, Ca plus O2 makes CaO. I rewrote it with blanks in front of each molecule or atom so that I have space to add my coefficients. And now what I'm going to do is I'm going to imagine that this equation has kind of a left and a right side, the reactants and then the products. So on each side, I'm going to list out the elements that exist, and they should be the same. Otherwise, I'm not going to be able to balance the equation. So I have a Ca and an O on the left side, and luckily I also have a Ca and an O on the right side. So now I'm going to count how many I actually have of each element. I have one Ca on the left, and I have two Os. I have one Ca on the right, and I have one O. So you can see the Ca's, the calcium's already balanced, but the O's are not. So when you're adding elements to the counting method, you're going to add a coefficient and then you're going to recount to see if it matches. So the first thing I'm going to do is I'm going to add a coefficient here because I need more oxygens. I need 2 in fact. And so I'm going to want to add a 2 here. What this does is this 2 distributes. So that gives us the 2 oxygens that we need, but it also distributes to the calcium because this is a whole molecule. So it's going to make it so we have 2 Ca's. Okay, so now we're going to have to go back and rebalance that. So we're going to have to put a 2 here to make that balanced. And that's it, we're done. We don't have to write any numbers on the O2. It's blank, that means it's a 1. That's its coefficient. So 2Ca plus O2 makes 2CaO. That's the final balanced equation. Let's do another example. Okay, so I'm going to start. Remember, we're imagining we have a left and right side, and we're going to start by counting how many of each element we have on each side. So there's Al and O on the left, there's Al and O on the right. Okay, so there's 2 Als, 3 Os, 1 Al, 2 Os. Let's start with Al, aluminum. I'm going to have to put a 2 here to get that to balance. Perfect. Now let's do the oxygen. Now this is a little trickier because we've got a 2 here and we've got a 3 here. Those are our subscripts. So no matter what number we add in front of the coefficients, it's going to be multiplied by those subscripts, remember. So I can't just add a 2 in front of the O2. Like I could, if I added a 2 there, I'd get a 4. And there's no way to turn 3 into 4, right? So I don't want to do that. What I want to do instead is I want to look for a least common multiple. So then you might remember that term from math. So the least common multiple between 2 and 3 is 6. So to get 6 oxygens on the right side, I would want to put a 3 there because 3 times 2 is 6. And to get 6 oxygens on the left, I'd want to put a 2 here because 2 times 3 is 6. But remember, it distributes to the entire molecule. So it's also going to multiply by our Al2. It's going to change it to a 4. It's fine. It's not a big deal. We can change coefficients after we've written them. So let's just change the 2. We'll change the 2 on the right side to a 4. Now it's perfectly balanced. So the final answer is 2 Al2O3s becomes 4 Al plus 3O2. Looks like 30, but it's 3O2. Okay, let's do the last example. So this one's a little bit harder. And the thing that makes it tricky is that there's elements that exist in more than one molecule on each side. And I'll show you what I mean when we start counting. So on the left side, I have N, I have O, I have H. I know there's another O here. I don't have to write it again. I've already written O once. And on the right side, we have the same 3 elements. I like to write them in the same order to make it easier to balance. So let's start counting. We've got 1 nitrogen. Now here, we have 2 oxygens here, but remember, we have another one here. So we actually have 3 oxygens. Okay, we've got 2 hydrogens. On the right side, we have 2 nitrogens. We have 3 plus 1, which is 4 oxygens, and we have 1 hydrogen. So let's go ahead and start with the nitrogens, since they're on the top. So we've got 2 on the right, so we need at least 2 on the left. Okay. That's going to change this to a 2, but it's also going to change our oxygens. So now we've got 2 times 2 is 4, but we also have this oxygen over here still. So we actually have 5 oxygens right now. Okay. I'm going to actually skip the oxygens and go down to balancing the hydrogens. If you want to know why I did that, go ahead and watch the tips and tricks video. I'll go into a little more detail. It's just easier to balance elements where there's one on each side. So let's go to the hydrogen. So we've got 2 hydrogens on the left, so I'm going to need to put at least a 2 here to get this to 2. Okay, that's also going to change my nitrogen. Now I have 2 plus 1, 3 nitrogens. Now I have 6 plus 1, 7 oxygens. Okay, let's go back and fix our nitrogens before we deal with the oxygen, because that's easy. All I have to do is change this 2 over here to a 3. Now that means that I actually have 3 nitrogens, and I have 3 times 2, which is 6 plus 1, 7 oxygens. Well, perfect. That balanced the oxygens for us as well. 372, 372. So the final balanced equation is 3 NO2s plus H2O becomes 2 HNO3 plus NO. Okay, so hopefully this video helped you learn the counting method of balancing equations. And eventually, if you get really good, you can actually almost look at an equation and balance it without even writing out the counting. You can kind of do it in your head. So that'd be super advanced mode. See if you can get there.